We come back to the third stratum that you already mentioned, the neurocerebral stratum, and I'm happy to introduce Danko Nikolic, our final speaker, not only for today, but also final speaker of the conference. And it's not that I think that neuroscience should have the last word, but it was just somebody has to be the last one. Einer macht das Licht aus. Danko Nikolic is a cognitive neuroscientist working here in Frankfurt at the Max Planck Institute for Brain Research. He's from Croatia, where he studied psychology, and he received his PhD in the United States. His main field of research is the electrophysiology of the visual cortex, studying distributed activity of a large population of neurons. In addition, he did extensive work addressing cognitive and perceptual processes, including synesthesia. His main scientific interest is the brain-mind explanatory gap, and Danko's main hope is that we will soon begin closing that gap. So we'll see.
But not today. Yeah, no, that's... Okay, so, Bernd, thank you very much for inviting me. So, part of my research is synesthesia research. And that's what I'm going to talk about, and that's what I promised Bernd to talk about. But what I want to do first is a little digression, because as the conference started 2 days ago, and yesterday I had a whole day to think, I came up with my second example of sound thinking that I want to present in this conference. So one example is from my research that will come in a moment. But the other example that I will show first is also from my research, but from a totally different perspective. It's not a result of research, but the method that we sometimes use to research the brain in the laboratory. And it's the following event. That's a typical recording of a signal from a brain. And as you can see, it's a little bit similar to recording of a sound signal. And what we normally do when we analyze those and we make complicated theories of how neurons interact, produce the dynamics in the brain and so on, we apply complicated mathematical analysis of, for example, Fourier transform, and we discuss it in very complicated mathematical language. Like here we would say the frequencies at low frequencies have more power than the high frequencies, and then something changes over time, and then at the frequency of 50 hertz, the power increases, and how it changes with the dynamic of the brain, and so on. It gets really complicated and very scientific. But I have one colleague in our lab who actually does a lots of sound thinking about it. After all this conversation we have discussing really complicated theory, he will come, Danko, basically what the brain does is the following. And he goes, shh. And so he, in a way, he takes this signal that you see first on the left, and he kind of makes a sound out of it, how the sound would look. So the first part would be more like a noise, and then later it would be more like a whistle because it's more oscillation and so on. And what I think is very important about it, about his approach, is that it actually helps understanding all this complicated theory behind. So even though we are well trained in this abstract mathematical thinking, and we can work with it very well, I think for everyone, it doesn't matter how well trained in these complicated things, it helps to have a very simple metaphor. And these simple metaphors that he uses now very proficiently I think help us very much to understand and do our work better. So I think it's one very nice example of actual sound thinking, where we use our natural biological system of processing sounds and use it in thinking about brain processing and so on. Right? Now back to synesthesia, a totally different example. So now this will be a little longer, and I will have more slides, and I will show you a little bit about my research on synesthesia. So briefly, I will introduce it. I suppose most people have heard of it, but maybe not everyone. So synesthesia is a phenomenon where it happens that people have associated have some strange associations, have strange experiences. So very common is grapheme color synesthesia. It happens for these people that they would have with a certain grapheme, like letter or a number, associated the color. So even though a letter would be presented in black or white and black, they would see a color associated every time, always the same nuance of a color. And these people are synesthetes. They are grapheme color synesthetes. There's also other types of synesthesia, like this one, where people would associate different months or days in a week with different colors, but also with different locations in a space. And they would have this real perceptual-like experience, vivid sensory experiences every time they think about October would be black, November could be pink, and so on, right? And located in a certain space, a location in space. That's another example of a person who I asked to draw her synesthesia for the months in a year. Synesthesia has different statistics, so some are very frequent forms, like you have top left time unit color, example of which I just showed you. 22% of synesthetes have this, and there are some really rare ones, like here on the right you can see 0.1%, 0.3% touch, smell, and so on, right? Now, what is important is understanding what synesthesia is about. And there are two sort of theories. There is a traditional theory, and that's related to the very word of synesthesia. So traditionalists believe that synesthesia is a union of senses. It comes from Greek word syn and aesthesis, which means basically union of senses, right? And this is an artistic illustration of this view, where it's thought that the senses are somehow connected. Actually, it's literally thought that there is a brain connection between auditory and visual, and there's actual axon grown of a neuron, and then these neurons activate each other, and that's why people have synesthesia. But what happened meanwhile, through the research of synesthesia, we realized more and more that actually there's a very strong semantic component to it. There's a very strong component of the meaning that a person assigns to the stimulus, right? So here's an example of experiment where you would present a subject with a letter O in a black color, and that was the only stimulus. But depending on the context, the person would have different synesthesia. So if it is O, if it's this shape, O-like shape, circular shape, in the context of letters, then the person interprets it as a letter, and then it has associated, for example, red color. But if it's physically identical stimulus in the context of digits, numbers presented before that, then the person would associate it as a number O, and that would be a letter. Then would be a color of a zero associated with that, right? So physically identical stimulus can produce different synesthesia, depending on the interpretation on the meaning given to that, right? And as we did more and more experiments, we came up with more and more evidence that this is what's happening. It's basically not a synesthesia as the word itself would say. So I came up with this word as close to the word synesthesia, but to reflect this new finding. And that's the word ideasthesia, because in the Greek, the word idea is the closest Greek word to the concept, right? So basically the word ideasthesia means sensing ideas or sensing concepts, which basically means the following, that we have some abstract concepts that we deal with. And normally, we who are not synesthetes, we don't have, these concepts do not really produce much of sensation in us. They're just abstract, maybe a little bit sensation here and there. But what synesthetes can do, and what they do very regularly, is they can attach to this abstract concept something very concrete. They can have a really vivid experience of a color or a location in a space or smell or touch or all kinds of things. And this can be very helpful in dealing with abstract concepts, especially for a child that is developing, that is learning new basic abstract concepts. It can help them a lot to attach these sensations. So here's the definition. I'll let you read it on yourself. I will not read it. So here's my my less artistic interpretation of ideasthesia, where in the center we have a concept. Everything starts from a concept. That's thesaurus reflects that. And then we have sensory experiences associated to different concepts, right? So there's no direct connection between sensory modalities, right? So we did lots of experiments and could always, again, found lots of evidence. One of these was a discovery of so-called swimming style synesthesia, where some people would have a different color associated with a different swimming style. It was very important to point out that they could have these associations also in the laboratory setting, when presented with images like this. They didn't need to be in a swimming pool swimming to have synesthetic experiences. And this was very strong evidence that it's not sensory inputs, but the meaning that they activate about swimming that produces synesthesia. But what is the most important case, I think, for us here for sound thinking is a very recently discovered case. So far we know just one case of a person that has something that we called mirror speech synesthesia. So there was this lady who contacted me. First, she was very shy and asked me all kinds of questions about synesthesia. And then when she felt that I wasn't dangerous to her, she started telling me about her various synesthesias, forms of synesthesia. She turned out about having 13 different ones associations. Some were very common that you see very often and are kind of boring for us. But this one was like totally never heard of and amazing. So what would happen to her when she would hear a person speaking, a voice of a person, she would feel in her entire body, in the throat, in the chest, all the sensations as if she's producing the sound. So it's mirroring speech of another person. This is in her words what she was saying. And what is important, of course, there is no direct connection from her auditory cortex to her chest muscles or something. Partly we know that because of her own description. It happens only in her mind. She knows, like all synesthetes always know what's reality and what's their own internal experience, and they can distinguish these two things. So can she. But also, I could ensure it by making a test. And I asked her about the sounds of animals and the sounds of, for example, the sound of whale. If you take a sound of whale and her experience, does she have this experience? And now it depends very much on her interpretation. If she's told that the sound that she hears is the sound of an animal, a whale, then she feels nothing. There's no synesthesia. It's exactly like us, hearing just the sound of whale. But you present her with the same sound and you tell her, well, it's a person making this sound. And then that moment, she feels like all the sensations as if she's producing that sound. Right? Now, so it's a semantic process, right? And it has to do with interpreting the sound and giving it meaning. And what I think is important here, what's a take-home message, is that no sound is a pure sensation directly input from air vibrations directly to somewhere in the brain where there is now pitch of a tone somehow represented the experience. It all goes somehow through our semantic interpretation of what we are receiving as an input. And all the experiences we have are somehow related to our knowledge and our interpretations of this experience. Therefore, to the concepts that we associate to these experiences, no matter how simple, how primitive, how basic, elementary they seem to be. Right? So at the end, it's all ideasthesia in one way or the other. Right? So in conclusion, we had two examples of sound thinking. One at a I would say at a higher cognitive level, right? Because the first one, right, where we had these examples that help us understand better our theories about how brain works, so it's pretty high level, at least we would think so. And then at the lower level, which is not yet, which is pre-language one, right? So that these effects, these sounds that one hears are not normally described by language. You don't have words for it. You don't explicitly think about them. And yet, there is a semantics and meaning playing a role, right? In both cases, it's a form of sound thinking. So thank you very much.